Okay, our next special rule is called the quotient rule. So when we have a quotient of two functions, we're going to use what we call the quotient rule. Okay, so if we have a function in this form, excuse me, a function divided by a function, then here is our derivative. If we call the numerator u and the denominator v, your derivative is vu prime minus u v prime all over v squared. To put it another way, if you were to think of your quotient as having two parts, a high and a low, then your derivative, this right here, can be summarized by low d high minus high d low all over low squared. So the low d high means you're going to write down what's down low and then multiply it by the derivative of what's up high. So d high is derivative of what's up high minus high d low, so we would write down what's up high and multiply that by the derivative of what's down low. Since we are subtracting, the order matters, and this is all over low squared. Okay, let's look at an example. We're going to do this one a couple different ways. The first way is to use algebra first. So if I were to divide all of these terms by 2x and simplify this before I use a derivative rule, it would look like this. Well, x squared over 2x, that's 1/2 x if we were to simplify it. Our middle term would become just minus 3, and our last term would be plus, those 2's would divide out. You'd have 1 over x, which is x to the negative 1 if we bring that up. So now if we were to use our power rule, we would have 1/2. The negative 3 would go to 0, and then we'd have minus a 1 x to the negative 2, which is the same as 1/2 minus a 1 over x squared. So this would be our derivative. Now let's compare it to the quotient rule. So over here, we'll do our quotient rule. So this does not require us to simplify, since we have a quotient, okay, a function over a function. We're going to start by doing low d high. So the low is 2x. The d high piece would be 2x minus 6. That's the derivative of what's up. Minus, so that's our low d high, minus the high, so x squared minus 6x plus 2. Okay, that's our high as is. And then d low, the derivative of what's down low, that would just be 2 all over low squared. Be careful. Don't make the mistake of writing your low squared like that. Do you see what I did wrong? Hopefully you're thinking you forgot parentheses. So if we were to simplify this, we would have 4x squared, so I'm just looking to distribute here, minus 12x. Here I'm going to distribute my 2, and I'm also going to make it negative because of the fact that that's negative right there. So a minus 2x squared. Then I would have a negative 2 times a negative 6x. That's going to be a positive 12x. And then I have this 2 times another 2, but I'm going to have to make it negative, so that's minus 4. So I have a 12x and a negative 12x, which will cancel. This is all over 4x squared. If I simplify this, I'm going to have 2x squared minus 4 all over 4x squared. And notice that if I were to simplify this, I get the same thing as before. Okay, so over here, this is the quotient rule, which does not require us to simplify. So we were able to do this one two different ways because in this function we were dividing by just one term. We were only dividing by this 2x. In our next example, we're dividing by two terms. We have an x squared and a minus 1. So it makes sense here to go right to our quotient rule. So low d high, there's our low, d high would be 5, minus high, so 5x plus 2, d low would be 2x, all over low squared, x squared minus 1, quantity squared. Typically we just tend to simplify the numerator. We tend to leave the denominator the way it is. So 5x squared minus 5. And over here I'd have a minus 10x squared. And then minus a 4x. And this is all over x squared minus 1, quantity squared. I can combine a couple more like terms, so minus 5x squared minus 4x minus 5 all over x squared minus 1, quantity squared. So this would be our derivative. One more example. We have a question here where we are looking to determine the points. Now what's implied there is the coordinates at which the graph of the function has a horizontal tangent. So what you need to be thinking here, if we're talking about a horizontal tangent, that's a situation where the slope is 0. All right, in other words, the derivative is 0. So we need to set f prime of x equal to 0 and solve. So let's do that. So let's find our derivative, y prime. We see that we have a quotient. So let's use our quotient rule. So low d high, that's just going to give us 1, minus high d low all over low squared. So quantity squared. So low d high minus high d low all over low squared. I'm going to set this equal to 0. Now if I do that, if I were to put this over 1 and cross multiply, okay, I'll also clean this up as I go. Distribute, distribute. So I would have, let me rewrite this here. We don't need parentheses. So we have x squared plus 3 after we distribute. And then we would have a minus 2x squared. And then we would have a plus 2x all over this denominator squared. Now if I put this 0 over 1 and cross multiply, notice that the 0 is going to wipe out the bottom. Okay, you'd have 1 times the top. So what's left here is just our top. So if I combine my like terms up top, I have 0 equals, I'm going to have a negative x squared plus a 2x and then plus a 3. Let's go up here. So again, if we're talking about a fraction set equal to 0, you just simply set the numerator equal to 0. You don't have to put that 0 over 1 and cross multiply. That's just to help you see that if you were to cross multiply, the 0 would wipe out the bottom. So it's really just the numerator set equal to 0. So I'm going to get this over to the other side so that my x squared term is positive. So I just brought my terms over to the other side, so I changed my signs. Well, this can be factored. This is going to be x plus 1, x minus 3 for our factors, which give us solutions of negative 1 and positive 3. Okay, so we just did basic factoring there. And now we need to find the y values that go with each of these x values, because it's asking for the points. So let's plug negative 1 back into the original function, not the derivative. We set the derivative equal to 0, and we found the x values that are going to have a horizontal tangent. So if you were to zoom in on these particular x values, you would actually see that it's either at a min, a low point like that, or at a max. Okay, that's where the tangent line slope is 0. So if you were to focus in on the tangent line slope there at these two particular x values, you would notice that it's 0. Okay, so we have to find the y values that go with these x values. So let's plug in. So with the first one, you would have -1 minus 1, that's -2, over -1 squared, that's 1, plus 3, that's 4. So our first one would be -1 comma -1/2. And our second one, plug 3 into that original function. You're going to have 2 over 3 squared is 9. 9 and 3 is 12. So our second one is 3 comma 1 over 6. So the final answer, the answer that we're going to select if it's multiple choice or box in if it's not multiple choice, would be this set of ordered pairs that we see. Okay?